Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about aldol condensation. There are three different aldol condensation reaction. Number one is a simple aldol condensation reaction. Number two is a cross aldol condensation reaction. Number three is a intramolecular aldol condensation reaction. With the help of suitable example, we have learned details of aldol condensation, and that aldol condensation is belongs to the nucleophilic addition reaction. Now let us look at as another reaction what we are going to discuss today. Look at here, Ester condensation, or this Claisen is a scientist name. He discovered this type of the reaction, therefore name is given to that reaction and is called as a Ester condensation. As we know that the ester, the word ester, we know that the organic compound having as a general formula R C double bond O R dash is called as a ester. This is a general formula of this ester, and as we know that ester, it is sometimes called as a derivative of the acid treated with the alcohol. The resulting compound form is called as a ester. So ester is one of the what we can call it as a organic compound. The simplest definition of that organic compound, the organic compound having general formula RC double bond OR dash is known as a ester, where there is a carbonyl group is present over there. But this, as far as this carbonyl compound is, if you talk about the reactivity of this compound, this carbonyl group has a slightly different reactivity than the carbonyl, and than carbonyl of aldehyde and the ketone. They are more reactive as compared to as a ester. So that is a thing regarding as here. What do the Claisen ester condensation means actually what? Ester clearly indicate that there are similar to as a aldol condensation reaction. Here also as a three types of the Claisen ester condensation. Number one is a simple Claisen ester condensation. Number two is called as a crossed Claisen ester condensation. And third one is a intramolecular condensation, but that is not the Claisen ester condensation. That is a different, that reaction is named, you might get confused here. The third intramolecular, not the intramolecular reaction is there, but that is the Dickmann cyclization. It is referred, it is called as a Dickmann cyclization. Remember here, Dickmann cyclization, nothing but there is a formation of the ring type of the compound is formed. This is just like as a intramolecular Claisen ester condensation, because Claisen is a scientist name. He work out the reaction for simple and the cross reaction, but intramolecular he did another scientist did that reaction, had done that reaction, and therefore the name of that reaction is named as a Dickmann cyclization, specifically it is known. And the Claisen ester condensation, this is a general method of synthesizing beta keto ester. This is a special method for synthesizing the beta keto ester, starting from ester having at least 2 alpha hydrogen atom similar to aldehyde, and the ketone as alpha hydrogen atom is an ester, is weakly acidic and react with strong base such as sodium alkoxide or sodamide to form the Carbanion, and this Carbanion attacks the carbonyl group of the another molecule, lead to the substitution product and two molecules of ethyl acetate is the simplest one. Ethyl acetate does condense in the presence of sodium ethoxide to give ethyl acetate or acetoacetic ester, and this the reagent synthesize the compound obtained, the reagent obtained by this process. The name of that reagent is a acetoacetic ester, or we can call it as a beta keto ester, or we can call it as a acetoacetic ester. The three are the alternative name of this compound. This is the compound is the versatile compound, variety of the organic compound we can prepare, we can synthesize by using as this compound. We will see later on the application how it is versatile, how we can prepare, because there is acetoacetic ester, there is a reactive methylene group is present. Reactive methylene group means what? It is present in between as a two flanked carbonyl group, and that's why they are highly acidic in nature. The base like as a ethoxide or the sodium alkoxide or sodamide, which can abstract the proton easily, form as a carbanion, and that carbanion you can treat with the alkyl halide, substitution product is formed, and further you can treat with the some of the suitable reagent. We will get the desired product. Whatever product you require, that kind of the product you are going to get over there. So that is the speciality of that Claisen ester condensation reaction, and that's why we are going to study there. Similar to as a aldol condensation reaction, the criteria first, the compound should be ester. In aldol we are taking as a carbonyl compound, maybe as a aldehyde or the ketone, but here the starting compound or the reactant must be as a ester. Which kind of the ester? It must have at least 2 alpha hydrogen atom. Then there should be as a alpha hydrogen atom must require there 2 alpha hydrogen atom. Then and then that reaction takes place, and we are getting as a resulting compound is acetoacetic ester or beta keto ester, which is a very important as far as the synthetic point of view is concerned. Variety of the organic compound we can synthesize by using as a acetoacetic ester, and therefore it is very important. Let us see here the criteria it require. First one is there must be as a alpha hydrogen atom, then and then reaction takes place, ester. And second one, the base is used over there like as a alkoxide or sodamide, this type of the strong bases are used to for the abstraction of that proton. And then condensation means two molecules get condensed together, and that's why the name is given as a Claisen ester condensation reaction. Now let's begin with the simplest. There are again as a three kind, I already told you that, but here the Claisen ester condensation, let us see. First one is a simple Claisen ester condensation. Simple Claisen ester condensation, a condensation reaction. Now let us begin with the simplest one. Simplest, you might be knowing the acetic ethyl acetate, right? Now here look at the 2 moles of ethyl acetate. This will be CH3, C double bond O, then O, CH2, CH3. This compound, I can write this compound in this manner also. CH3, C double bond O, then C2H5, or I can write this compound maybe as a CH3, C double bond O, and ET. ET means ethyl group, one and the same thing. Remember, there are the 3 different ways to represent the ethyl group. ET means what? This one, CH2, CH3 group. or we can write this CH2 group we can write as a C2H5, means these two carbon atom, there are 5 carbon atom, and so these are the various, this is known as a ethyl, and the name of this compound is a ethyl acetate, right? The name of this compound is a ethyl is a this one, and this part is called as acetate part, and therefore the name of this compound is a ethyl acetate. The name of this compound is a ethyl acetate. Ethyl acetate. This is a ester used over there. Ethyl acetate as a ester used here. In presence of the alkoxide, you can write as a NaOET, or we can write like this, or ETO Na also. Or here, as we know that the sodium atom always carries as a positive charge, and where the oxygen atom has the negative charge over there. Now this is a strong base, we can write like this, or we can write as a CH3 CH2O Na, or we can write this one C2H5O Na, like this also. So that are the various way to represent, to write this compound, and the product we are going to get here, the product I am directly writing as a product over here. The product you are going to get here, CH3, then C double bond O, then CH2, then C double bond O, OET. See, OET, you know that ET means ethyl group. And now the name of this compound, look at, this is a carbonyl group, and therefore adjacent to that you can call it as alpha. This one is a beta. The keto group, carbonyl group of that keto present at beta position, and therefore it is known as beta keto ester. The name of this compound is a beta keto ester. As I already told you that it is a very versatile reagent. Variety of the organic compound we can prepare by using this one. Why? I will tell you later, or I am going to tell you shortly. Now the another name of this compound is ethyl acetoacetate. Ethyl acetoacetate. Short form of ethyl acetoacetate is EAA, right? It is also termed as ethyl acetoacetate, means EAA, or we can also call it as a acetoacetic ester, acetoacetic ester, and it is abbreviated as AAE, like this. So there are the various name of this organic compound, because this is a versatile. Why it is a versatile? Let us look at over there. This CH2 group is known as a reactive methylene group. Reactive methylene group, CH2 group. Reactive methylene group. Why it is termed as a reactive methylene group? One more question may appear in an exam. Remember what it is known as a reactive methylene group, because this is known as a reactive methylene group. The reason behind it, this CH2 group, methylene group present in between the two flanked carbonyl group. Look at here, this is a carbonyl group, this is also as a carbonyl group, and they are the electron withdrawing group. This is also as an electron withdrawing group, this is also as an electron withdrawing group, and therefore these protons are highly acidic in nature. Whenever you are using as a base over here, form as a carbanion, and that carbanion are well stabilized by the resonance, and that's why it is referred, or it is called as a reactive methylene group. Remember here, what do you mean by the reactive methylene group? Such type of the reactive methylene group may occur in some other organic compound that we will see at the time being. Here only we are talking about this one. So now how do you get this product? Why we are writing as this product? Because after treating these two molecules of ethyl acetate, resulting into as a beta ketoester or ethyl acetoacetate, or we can call it as acetoacetic ester. So because I am knowing the mechanism behind it, and now I am going to show you the mechanism, how that mechanism takes place. Let me again tell you the definition of the mechanism. As we know that mechanism is a language of organic chemistry, a detailed study of sequence of steps which are involved in the conversion of reaction into product is known as reaction mechanism. And generally the organic reactions mechanism are taking place via two pathway, or what we can call it as, there are the two ways to occur the organic mechanism. One is proceeding via ionic, and second one is a proceeding via free radical. So this is the reaction proceeding through ionic mechanism and the free radical mechanism. Let us see how we are getting that compound. Here I am going to show you the mechanism of that compound. Now let us see here. Just now we have got that compound CS3, C double bond O, then CH2, C double bond O, and OET, right? This compound is known as a beta ketoester or acetoacetic ester or ethyl acetoacetate, or we can call it as a beta ketoester, right? Just now we have seen. Now we are talking about the mechanism of that beta ketoester, how the mechanisms are taking place over there. Let us see. I think the mechanism involves three steps. Step number first is a generation or formation of the carbanion. So how it forms over there, because we know that I am writing specifically for the sake of convenience of mechanism, one of the hydrogen atom like this, then C double bond O, OET over there. And now whenever we are using as a sodium ethoxide here, plus and minus charge, what is going to happen? ETO minus, this alkox ethoxide will abstract the proton from here and form as a carbanion over there, and you are going to get the product over here, CH2 minus charge, then C double bond O and OET. Look at here, this species. What is this species? This is a carbanion, right? This is a carbanion. The negative charge present on that carbon atom, that type of the species is called as a carbanion. And further there will be a delocalization, there forming as a double bond over there. That oxygen atom carries as a negative charge, therefore we are getting CH2 double bond C O minus over there and OET. So this is, and when adjacent to the carbon-carbon double bond, oxygen carries negative charge, that type of the species generally known as enolate, right? And during that aldol condensation reaction, we already familiar this word. So let's see this one again. Once again, this is a step number first we have seen. Now let us look at as a step number second. So this is a step number first. Now is a step number second. In the step number second, take the same. Now simple Claisen ester condensation reaction means what? First, the same molecule we have taken, we have considered here as a ethyl acetate, one of the ethyl acetate, another also as a ethyl acetate. Same molecule, identical molecule we have considered over here, and that's why now I am writing another second molecule CH3, C double bond O. I am writing OET for showing the mechanism point of view. I am showing this ethyl acetate this way, and then there will be CH2 double bond C O minus over here, and then OET over here, right? Now this is the enolate, and this is the our ethyl acetate of the second molecule. Now what is going to happen over there? This negative charge forming as a double bond between carbon and this oxygen atom. At the same time, this double bond is going to attack on this carbon atom and negative charge develop on that oxygen atom, and we are going to get over here this one CH3, then CO minus, and then OAT, that is as it is, and plus, not plus, then bond form between this CH2 and then C double bond O and OET. There is a alkoxide type of the species is formed over there. Now what is going to happen? Step number 3 over there. Now this compound I am writing as it is over here, CH3, then CO minus, then OET, then here is a CH2, C double bond O, and then OET. What I did over here, I am just writing this compound as it is over here and calling it as a step number 3. Now observe this reaction carefully. What do you see over here? This negative charge coming down, forming as a double bond with that oxygen atom. At the same time, it pushing that OET because it is a good living group over there, and that's why it is pushing that OET alkoxide group is further away, and we are going to get here CH3, then C double bond O, now is a CH2, and then C double bond O, OET, that type of, and this is the resulting compound we are getting over there, which is known as beta keto ester, right? This is a beta keto ester, or we can refer as a ethyl acetoacetate or acetoacetic ester. In this way, we have seen the complete reaction of that simple Claisen ester condensation. You understood this? Now let me give you one more example so that do you able to predict the mechanism or not. Let me check your thing. Now let us see here one more example which will explain how that the compound you are going to get over here. Let us see the example of this. Now here let us see here CH3, then CH2, C double bond O, OET. Two molecule of that propanoic ester we are using here in presence of sodium ethoxide or sodamide, two molecule. What would be the product you are going to get? And the product you are going to get over here is this one CH3, then CH2, C double bond O, now is a I think CH3 over there, and then what is that? C double bond O, OET. This will be the product you are going to get. Still there is a one protons are there which is highly acidic in nature. So monoalkylation you can carry it out on these reactions. So in this way we have seen the complete mechanism as well as fully understanding of that Claisen ester condensation, which is a simple Claisen ester condensation reaction we have seen. Now tomorrow we will see the next reaction, which is a cross Claisen ester condensation. I think with this let us stop today here. Remaining we will see the next time. Thank you. Have a nice day.